Welcome to The Explainer. So, you've probably chatted with an AI, right? Maybe you've asked it to whip up an email for you or even a poem. But have you ever stopped to wonder how an AI like that is actually built? It's not magic, not by a long shot. It's this huge, fascinating process. And today, we're going to pull back the curtain on the complete life cycle of a large language model. Okay, so we're going to follow its life story in 5 key stages. We'll start with building the brain, then learning to talk, finding its moral compass, thinking on its feet, and then we'll peek into what's coming next. All right, let's dive right in. So every single AI has to start somewhere, right? And that's with building a foundational brain. This process is called pre-training. Honestly, the best way to think about it is like a library phase. The brand new AI's one and only job is just to read. And I mean read a lot. So what does that actually mean? Well, during this pre-training, the model gets fed just a colossal amount of text. We're talking the internet, books, articles, you name it. But here's the key. It's not learning to answer your questions yet. Not at all. It's just using this clever technique called self-supervision to absorb the fundamental patterns of human language. You know, grammar, basic facts, and how words connect to each other. And how it learns is pretty wild. It's basically playing a giant game of fill in the blanks over and over again. This is a technique called masked language modeling. So the model sees billions of sentences, but with some words hidden or masked. And its only job is to guess what those missing words are. And with every single guess, it gets just a tiny bit better at understanding context and the relationship between words. And the scale here, it's just staggering. I mean, take a classic foundational model like BERT Large. It has 340 million tunable parameters. Think about that. You can imagine them as tiny little knobs that the AI gets to adjust with every single correct guess it makes, slowly refining its understanding of all that text. Okay, so our AI has now read a library bigger than any human ever could. But it's kind of like a brain in a jar. It doesn't know how to follow instructions or have a real conversation. So that brings us to the next stage, the school phase. This is where we teach it to actually be useful, using things like prompting and fine-tuning. Now, one of the coolest things about this phase is something called in-context learning. This is where we can teach the AI a new skill without having to do that massive retraining all over again. For example, in what's called a zero-shot scenario, we just give it a task. Say, correct some grammar. It might get it right, it might not. But check this out, with few-shot learning, we just show it a couple of examples first. And that little demonstration, that's often all it needs to get the pattern and do the task perfect. But what about more complex problems? Well, we can actually get it to think out loud. There's this incredible technique called chain of thought prompting that does exactly that, and it's almost ridiculously simple. You just add a little magic phrase like, let's think step by step. That's it. And just by doing that, you encourage the model to lay out all its reasoning, which dramatically, and I mean dramatically, improves its accuracy on things like logic puzzles and math problems. It's not just jumping to an answer anymore, it's actually showing its work. Okay, so having a super powerful brain isn't enough, right? I mean, you also need that brain to be helpful, to be honest, and most importantly, to be harmless. This brings us to a really crucial stage, the character building phase. Technically, this is known as alignment. So, how do you guide its behavior? Well, there are 2 main paths we can take. The first one is called supervised fine-tuning, or SFT for short. That's where you teach it by example. You show it thousands of really high-quality instructions and the perfect answers to go with them. The second method is a bit more complex. It's called reinforcement learning from human feedback, or RLHF. And here, we're not showing it perfect answers. Instead, we're teaching it based on our preferences. Yeah, RLHF is a really clever process. Here's how it works. First, you get the model to spit out a few different answers to the same prompt. Then, a human comes in and ranks those answers, from best to worst. Now, all that ranking data, we use that to train a whole separate AI, called a reward model. And its only job, literally its only job, is to develop good taste. It learns to predict which answers humans are going to prefer. This reward model then becomes like an automated coach, constantly guiding the main AI to give better and better answers. All right, our AI is now educated, it's aligned, it's ready for the real world. It's time for it to get a job, and that job is answering your prompts. This is what we call the work phase, or what the industry calls inference. So when you hit enter on a prompt, something really interesting happens. Generating that response is actually a two-part process. First, there's what's called prefilling. Think of this as the AI taking a deep breath and reading your entire prompt all at once. It's a heavy, compute-intensive step just to get the context. Then comes decoding. This is where it starts generating the answer, but it does it one word at a time. This part is all about memory speed, because it's constantly checking its short-term memory, its KV cache, for what to say next. And that's exactly why you see the text typing out word by word. And believe it or not, the AI doesn't just have one way to answer you. It actually has different strategies for how it picks the next word. There's greedy search, which is the fastest. It just picks the absolute most likely next word every single time. It's fast, but it can get a little boring and repetitive. Then you have beam search, which is a bit more thoughtful. It explores a few different sentence paths at once, and then there's a technique called top P sampling, which kind of gives it a spark of creativity. It picks from a small group of likely words, which creates this really nice balance between being creative and still making sense. So there you have it. We've seen how a large language model is born, how it's raised, and how it's put to work. But the story definitely doesn't end there. The future of how these things grow, it really boils down to one single powerful idea. And that powerful idea is captured in something researchers call scaling laws. What they've found is this: as you increase a model's size, the amount of data you feed it, and the raw computing power you use to train it, its performance gets better. And it gets better in surprisingly predictable ways. The bottom line from the research is, for these models, bigger is quite literally better. It's almost like we found the recipe for making smarter AI. You just add more data, you build a bigger model with more of those little knobs, those parameters, and you throw more computing power at it. And this combination, it reliably leads to better performance. But here's where it gets really fascinating. This very predictable improvement, it leads to something completely unpredictable. You see, as these models get bigger and bigger, they start developing what scientists call emergent abilities. These are skills like complex reasoning or even doing math that they were never, ever explicitly trained to do. They just appear. And that leaves us with a final, pretty mind-bending question to think about. If just making these things bigger makes them smarter in ways we don't expect, what kind of abilities